Okay, let's dive into another video. This one is Chapter 1, Section 4, and we're going to be looking at adding and subtracting real numbers. Now, the real emphasis here is adding and subtracting fractions. Excuse me. But you should all be very familiar with adding and subtracting fractions. So we're going to approach it a little differently. Not only will we be working with fractions, but we're going to be looking at patterns as well. So I've got some problems here. We're going to start with Stevens, and you can try and figure out what the category is as we go along. But we've got the problem 1/5 plus 1/10 plus 1/15 plus 1/30, and we want to figure out what is that expression equal to. So what we know is that if we're going to add or subtract fractions, we have to have common denominators. So I'm going to rewrite this so that they all have the same denominator. Now if you look at the denominators, 5, 10, 15, and 30, the lowest common denominator is 30. So each one of these is going to be written as a fraction over 30. All right. Now, to go from 1 over 5 to something over 30, we're multiplying by 6, because 5 times 6 is 30. So this becomes 6/30ths. And then to go from a 10 to a 30 is times 3, so 1 times 3 is 3. To go from 15 to 30 is times 2, so 1 times 2 is 2. And this one's fine the way it is, as 1 over 30. Now, these all have the same denominator, so we can combine them. 6 plus 3 plus 2 plus 1 is, did you get 12? So this is 12 over 30. And then remember, if you have a fraction that can be written in smaller numbers, reduced, we call it reducing them, then you should do that. 12 and 30 are both divisible by, did you get 6? 12 divided by 6 is 2, and 30 divided by 6 is 5. So this expression is equivalent to 2/5. Let's try another one. Now we've got 1/2 plus a 1/4 plus a 1/6 plus a 1/12. The least common denominator here is going to be 12, because 2, 4, and 6 all go into 12. So I can rewrite this as something over 12 plus something over 12 plus something over 12 plus something over 12. Now, to go from 2 to 12 is times 6, so 1 times 6 is 6. To go from 4 to 12 is times 3, so 1 times 3 is 3. From 6 to 12 is times 2, and then we have 1 there. Add up the numerators because the denominators are the same, and we get 12 over 12, which equals 1. Okay, let's do another one. 1/3 plus a 1/6 plus a 9th plus an 18th. Now, our least common denominator is 18, so I'm going to have something over 18 plus something over 18 plus something over 18 plus something over 18. 3 times 6 is 18, so that'll be 6. 6 times 3 is 18, so that'll be 3. 9 times 2 is 18, so this will be 2, and this stays 1. Add them up, and we get 12 over 18. Those are both divisible by 6, and so we get 2 over 3. Now, as I was doing these, hopefully you saw something. You saw a pattern in what I was doing. Okay, let's back off this a little bit. There was something common in all three of these examples, and that is when we converted to the least common denominator, we always ended up with a 12 in the numerator. Okay, so what's going on here? And there's also another thing I want to show you is going on, but I'm going to get to that in a second. So there's a pattern here. If you look at this, let's describe this as 1 over n is the first number. So in this case, n would be 5. In this case, n would be 2. In this case, n would be 3. So 1 over n. To that, we are always adding 1 over 2n. So let's take a look. If n is 5, 2 times n is 10. If n is 2, 2 times 2 is 4. If n is 3, 2 times 3 is 6. Then we add 1 over, now, what times 5 would get me to 15? It's times 3. What times 2 would get me to 6? That's also times 3. And what times 3 would get me to 9? Also times 3. So now we've got 1 over 3n plus, and the final one is going to be 1 over 6n, because 5 times 6 is 30, 2 times 6 is 12, and 3 times 6 is 18. So that's what was common in all these. Now, I want to simplify this, but before I do that, I want you to look at the solutions. We've got 2 over 5, 1, and 2 over 3. Do you see a pattern in the answers themselves? Okay? And here's your hint. Compare the answer we got with the original 1 over n, or the original first fraction. Now, do you see a pattern between 1 over 5 and 2 over 5? 1 over 2 and 1? 1 over 3 and 2 over 3? Do you see a pattern in the answers? Well, let's dive into it here and see if we can figure out what that is. Well, what I'm going to do is I'm going to split up these fractions a little bit. I'm going to say that 1 over 1 times 1 over n, well, 1 over 1 is 1, and 1 times 1 over n is 1 over n. I can split up the second fraction as 1 over 2 times 1 over n. The third fraction can be 1 over 3 times 1 over n. And the last fraction can be 1 over 6 times 1 over n. All right? I'm going to zoom in a little bit. Notice that what's common in each one of these terms, the terms are separated by the addition sign. So what's common in each one of the terms is 1 over n. So I'm going to do what's called factoring that out. I'm going to pull that out, and I've got 1 over n times, what's left behind is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 6. Now, just to convince yourself this is true, if I were to distribute 1 over n to all four of these fractions, I would get the line above. Okay? So if you need to, pause the video and convince yourself that by factoring out 1 over n, I get this, and this line is still equivalent to the line above it. If you have to, pause the video. So let's keep going. I've got 1 over n times, now let's make all these have common denominators. Okay? 1 is 6 over 6. A half is 3 over 6. A third is 2 over 6, and 1 over 6 is 1 over 6. So I've got 1 over n times 6 plus 3 is 9, plus 2 is 11, plus 1 is 12. This is 12 over 6, which is the same as 1 over n times 2. So now let's go back and look at what we got as results. Notice that 2 over 5 is equivalent to 1 over 5 times 2. 1 is equivalent to 1/2 times 2. And 2 over 3 is equivalent to 1 over 3 times 2. So because these problems set up in the same pattern, I was able to establish a pattern in the results, which is just take that first fraction, multiply it by 2. So we're practicing fractions and we're looking for patterns. Let's look at another one. So this one is called Tabby. So have you figured out what the category of the problems today is? So let's dive into this one a little bit. We've got 1 plus a half. What's that equal to? Hopefully that didn't take you long, and you got 1 1/2. Okay? Now let's continue the problem. I've got 1 plus 1/2 plus 1/4. So what do you get there? Well, 1 plus a half is 1 1/2, and 1 1/2 plus a fourth is 1 3/4. Don't trust me? Pause the video, convince yourself. Let's continue the pattern. 1 plus a half plus a fourth plus an eighth. So the pattern here is that these fractions are being decreased by half each time. So half of a half is a fourth, half of a fourth is an eighth, and we're adding that on each time. And if you do the arithmetic here, and I encourage you to do it, I'm just going to write it down to keep the video a little shorter, you get 1 7/8. 1 plus a half plus a fourth plus an eighth plus a 16th is 1 15/16. Now, how did I do that arithmetic so quickly in my head? Well, I've recognized a pattern. Here, watch. I can do it again. 1 plus a half plus a fourth plus an eighth plus a 16th plus a 32nd equals 1 31/32. Do you see the pattern now? Okay, let's do another one. I've got 1, my screen went blank again, 1 plus a half plus a fourth plus ... We'll just go like that to 1 over, let's do 128 this time. So I've got half, 1 plus a half plus a fourth plus an eighth plus a 16th plus a 32nd plus a 64th plus a 128th. What I did there is I skipped the 1 over 64. And I can see, I don't have to do the arithmetic because I see the pattern. This is 1 and 127 over 128. Now, hopefully what you're seeing is the pattern where the fraction I get is the numerator is 1 less than the denominator. 1 less than 2 is 1. 1 less than 4 is 3. 1 less than 8 is 7. 1 less than 16 is 15. 1 less than 32 is 31. And 1 less than 128 is 127. So we're practicing fractions, but we're looking for patterns. So what we've got is, if I were to write this in generic terms, I've got 1 plus a half plus, and we just keep that pattern going, up to plus 1 over n. So in this line right here, n would have been 128. In this line, n would have been 32. In this line, n would have been 16, and so on up the line. And the pattern I saw is that the answer is always going to be 1 plus 1 less than, sorry, that's a minus sign, over n. And that's what I'm getting. See, 128, 1 less than 128 is 127, so it's 127 over 128 plus the 1. And there's a really unique way to prove this, if I can find my straight edge. And it's called proof without words. And if you ever get a chance to look into proof without words, it's kind of an interesting way of looking at stuff. But let's diagram this. So I'm creating squares. And I'm going to put a plus sign in between them. Now, in every single one of these, I had that integer 1 out in front. So I always have the 1. Okay? In the next one, I had a half. So 1 plus a half. In the next one, I added a fourth. In the next one, I added an eighth. In the next one, I added a 16th. And then a 32nd. And then a 64th. But you'll notice what was missing in each one of those is the, like here, when I shaded the 1/2, 1/2 wasn't shaded. Then when I added the fourth, there was a 1/4 that wasn't shaded. Then when I added the 16th, and so on down the line. So we've got 1 plus n minus 1 over n.